one of the first things you need to do when you're going to optimize your NoSQL database and your interactions with it is to think about, do you want to optimize a particular piece of data and the access to that data for read versus write? And this is a fundamental question that you need to ask, because it vastly changes how you want to store and interact with that data. So let's take an example, and we'll relate it back to our original Java map example to help understand why knowing if you're going to go for reads versus writes is critically important. So let's say that we have a forum, and we would like users to be able to post comments, let's say on our videos. So users can go and they can post a comment, and on the page we would like to be able to display the number of comments that have been posted by each user. So somewhere on the display, if a user's comment is there, we might have user foo, and we might have some number of comments that they've posted across all the forums, let's say, just for simplicity. So one of the things we need to be able to do is we need to be able to keep track of this count of the number of comments that they've posted. So there's kind of two approaches that we could do. One approach is we could have a table where every time some structure where every time the user posted a comment, it would be entered as a separate entity in this particular store. And so I'm using the entity name very specifically here, because we're going to go and create a Java class to represent a comment. We're going to annotate it with something like @entity, and each time they create a new comment, we're going to create a new instance of that object, and we're going to store it in the list of comment objects. So we've got these comment entities or objects, stored objects, that represent each time the user goes and posts a comment. And so there might be some number of these. Now, the way that we're going to generate the number of comments is each time we load this page, a request will go to this table, and we will search for all comments where the user is a particular user. So find all comments with particular user and count them. So as you can see, this is an operation that is very cheap from a write perspective and very expensive from a read perspective. So if I want to write and add a comment, then what I have to do is just create a new instance of a comment object and add it and store it so it's persisted. But there's no locking or any other things that I have to worry about, because it will never be the case that multiple writers, hopefully, are writing to the same comment at the same time. If the user is on the page entering a comment and hitting save, they're going to be the only one, theoretically, creating that comment. They're hopefully going to be on one page at a time, but they're creating one comment. And there's only one person logged in. And even if they had multiple browser tabs open, or for some reason their child is commenting as well simultaneously, none of those comments conflict with each other, because they're all each atomic entities that would be edited separately. So each time they click add, it's adding a new entity in here. So comment creation, the write, is really cheap because there's no locking of the database, no worries that multiple people will write to the same comment at the same time. However, our reads are really expensive. If we think back to that Java map example, where when we wanted to know which people had bought a particular item, we had to go and search through and scan through all of the data and all of the values, looking for ones that met our particular criteria. In this case, we're doing something similar. When we want to know the count for a particular user, what we have to do is count all of their comment entity objects and then create the sum of that and return it. So it's an expensive read operation. So read is slow, write is going to be fast in this case, or at least they're optimized to make reads slower and writes faster. Now, if what we really cared about was getting the number of comments quickly, what we could do is instead we could have another table, and we could have entities in this, which it were comment count. Now, in this case, and we'll just go ahead and make this by user. So if you want to know the number of comments that a particular user has left, we're going to do something equivalent to what we did with the maps in Java. That is, we're going to create a new map or a new table or whatever you want to think of it as. And the entities in here are these comment count objects that we are persisting. And every time you want to get the comment count, all you have to do is push in the user as the key, and the comment count pops out. So it's a very simple key-based lookup to get a particular user's comment count. But the difference is that every time that we go and add a comment now, we're going to also have to go and update the comment count. So writes are getting more expensive, because now if we add a new comment object, we also have to go here and update the comment count. And we might want to do this in a transaction so that it's atomic, and you can't add an object here and then not have it update here, or update here and not work over here. So we might have some transaction issues. We also might have the case where if this user's child is creating comments at the same time, we can't just assume that we don't have to worry about locking. We have to lock this object, particularly if there's any situation where the user could be logged in multiple times. Somebody else is using his account. Now, maybe that doesn't make sense, but you could think of scenarios where you could have multiple writers to the same object. In this case, we have multiple potential writers to the comment count. So if the user posts multiple comments in a very short order from multiple tabs or something else in their browser, they will all simultaneously be trying to create comment objects here, and then simultaneously trying to be right to the comment count. So we'll have to do some locking on this particular count to make sure that we don't end up with inconsistent data. Also, we'll probably want to have some type of transaction to make sure you can't add a comment and not update the count, or vice versa. So in this style over here, the writes are slow and the reads are fast. So this is a thing you're going to see over and over when you're designing for NoSQL and trying to figure out, how do I design my entities to fetch them? Well, we can go and we can duplicate some of the data. We're suddenly having another representation of the comment count. And we can just make this a Java class called comment count. There's a key for users. But the downside is that suddenly we are sort of making our writes more expensive. However, we don't have to have this thing. We can just have a list of comment objects that are essentially being added. Each time we persist a comment object, they're being added to the table or whatever it is that you're storing these things in. But when you need to know the comment count, you have to go and actually scan through all the data like we were with the map and get that count back. So before you begin doing anything and you want to look at a particular query, you need to understand, how often am I going to be writing? How often am I going to be reading? Is it more important that my writes be fast, or more important that my reads be fast? And that's what you're going to need to know in order to begin to make reasoned decisions about how you should structure your classes that are annotated with entity and stored, or how you're structuring your classes that are annotated with whatever you're going to use to map them into the underlying NoSQL data store. If you're going to be writing a whole lot, people are going to be writing lots of comments, and you want to make comment writing really fast, then you'll probably go for something like this. If, however, every time that you load this page, there's thousands of comments, and getting the number of comments for each user is incredibly slow and is the bottleneck, then you're going to want to do something like this. And so until you know what is it that you're trying to optimize for, are you trying to optimize for writes, or are you trying to optimize for reads, you really can't go forward with figuring out how to structure your data to make it easy to access.